Good morning, students. In this class, we are going to discuss about Melde's experiment. Melde's experiment. Aim of this experiment is to determine frequency of electrical vibrator or tuning fork. Okay, aim of this experiment is to determine frequency of electrical vibrating tuning fork in two methods: transverse method, longitudinal mode, and transverse mode. Operators using in this experiment: Melde's operators, a tuning fork, battery eliminator, pulley with stand, pan, weight box, meter scale, and connecting wires. Okay, so I will show you operators. This is a tuning fork, electrical vibrator or tuning fork. Some voltage is applied through the battery eliminator. This is a battery eliminator. This is a pulley. This is a pulley attached to the table through stand. This is a pan. This one is weight box. So we are having a weights in this box. Okay, 10 grams, 5 grams, 10 grams, 20 grams, like that. These are operators of Melde's experiment: tuning fork, battery eliminator, pulley with stand, and a pan. This is a pan, weight box, and meter scale also. Meter scale and connecting wires. So these are connecting wires. These are the operators of Melde's experiment. Formula is, so we are calculating a frequency of tuning fork in two ways, in two different modes. The first one, longitudinal mode. In this mode, frequency mu is equal 1 by L into under root of T by M. The root of T by M. Okay, longitudinal mode. So this is diagram for a longitudinal mode. A tuning fork adjusted so that vibrations parallel to the length of the thread. So it is a longitudinal mode. Formula mu is equal 1 by L square root of T by M. In this formula, L stands for each loop length or average length of the loops or each loop length. T is tension in string or tension in thread. The tension is equal to mass into acceleration due to gravity. The mass attached to the string at one end into acceleration due to gravity. So first end is connected to the tuning fork. Second end of string is added to the pan with some weights. In this formula, M is mass of the pan. Capital M is mass of the pan. M1 is applied load in pan. The total mass is equal to M plus M1. It should be taken in grams. G is acceleration due to gravity. Its value in a seizure system 980 centimeter per second square. In MK system 9.8 meter per second square, but in a seizure system 980 centimeter per second square. Right? And small m in this formula, small m stands for linear density of thread. Linear density of thread. Linear density, you can determine linear density using this formula: mass of thread divided by total length of the thread. Linear density means total mass of the thread divided by total length of the thread. So another method, that is a transverse method, transverse mode. In this mode, frequency of vibrator at tuning fork nu is equal, formula nu is equal 1 by 2L into square root of T by L. Okay, so L is average length of the loop or each loop length. T is the tension in a string or a thread. Small m is the linear density of the thread. Okay. Now see this experiment. Set up this tuning fork. This tuning fork, one of the prong connected to the thread. That means the thread first end is connected to the tuning fork, and other end connected to the this pulley through this pulley stand. So connected to the pan through this pulley stand, right? So some weights are placed in a pulley to create tension in the string. So here this is a longitudinal mode arrangement. This is set up represent longitudinal mode. Longitudinal mode, because the tuning fork make a vibrations parallel to the length of the string. The vibrates parallel to the prongs vibrate parallel to the length of the string. So you can say that this is a longitudinal setup, longitudinal mode setup, right? Now we are applying some voltage, that is suitable voltage, 6 voltage. Whenever power off, power on, tuning fork get vibrations. That vibrations will pass to the thread. Here some weight of 10 grams are added in a pan. 10 grams added in pan. So it provide a tension in a string. Then a loop will form in this portion that is in between tuning fork and pulley. In this portion, tuning fork and pulley, vibrations loops will be formed. Okay, loops will be formed. Okay, here first loop, second loop, and third loop. Okay, here 3 loops are formed. 1, 2, 3. 3 loops are formed. Now take these total loops length from tuning fork to pulley. The total length of the loops, that is from tuning fork to pulley, right? So it is gives a total loops length. So how many loops are formed here? 3 loops are formed. 3 loops forms we have to note in this table. Okay. You see here observation table, serial number. The first column, mass in pan, that is M1, capital M1. Total mass M plus M1 grams. Tension in string. Tension formula T is equal total mass into G. Next, the length of the N loops. So here length of this column representing length of N loops, and length of the next column, length of each loop. It is denoted by small l. Okay, length of each loop, or average length of the loops. Those are formed in a procedure, right? Next, last column gives root T by L value. Root T, root of tension divided by L, right? So in here mass of the pan, mass of the pan, that is a small capital M, mass of the pan 20 grams, the standard value, that is weight of the pan, M is equal 20 grams. So we are adding a different mass, mass, 5 grams, 10 grams, 15 grams, 20 grams, 25 grams, 50, like that. And we are increasing our weight in a pan step by step. Okay. So here first we have taken 5 grams load. For 5 grams load, tension is equal, mass is equal 20 grams, that is a mass of the pan plus added mass 5. The total mass attached to the string is 25. Okay. First reading, I am discussing about first reading. 20 is a mass of the pan. We should consider mass of the pan every time in this table. That is 20 grams plus adding mass, that is 5 grams. Okay, 5 grams. So this is the 10 grams, 5 grams added mass, 5 grams. Tension in a string is equal to T is equal 25 into G value 980. That is the tension in string. So you can calculate it by multiplying 25 and 980. 25 is the total mass attached to the string, 980 acceleration due to gravity value. Length of the end loops. Length of the end loops. So we have to measure total loops length from tuning fork to pulley. That gives a total loops length. Total loops length in centimeters. For example, here that is total length is 1 meter plus 100 centimeter plus 113 centimeter. Total length of the loops, n loops. So how many loops are formed here? 3 loops. So this is a 3 loops length. Length of the each loop. Length of the each loops is equal to 133. The total loops length divided by number of the loops. How many loops are formed here? 3 loops are formed. So 113 divided by 3, that gives a average length of the loops or each loop length. That is a small L value. Okay, small L is equal 113 by 3. It gives a average loop length value. Okay, next last column. So already we calculated T value. That is 25 into 980. Take a root over this value, and you can get a root T value divided by L value, this value. Okay, that is the root of 25 into 980 divided by 3 is 9, 2 into 2 3 7, 37. Each loop length is 37. So in this way I can calculate one value, one reading in a longitudinal mode. In this way every time so we have to add some weight in a pan and do this process, and we will get T value and average length of the loop. Okay, in this way I can calculate all values of L root T by L to root T by L for different weights, different mass. So after that calculate average value of the root T by L, average value of the root T by L. So here, and substitute that value in given formula. What is the formula? Formula nu is equal 1 by L under root T by F. So this is equal to, you can write another form, 1 by root M into the root T by L. Root T by L. Substitute the value in this formula. Before that we have to calculate root m value, linear density of the thread. So what is the formula? M is equal to total mass of the thread. Total mass of the thread, that is a 0.8 grams, which will have to calculate that mass using a simple balance. So here mass of the thread is 0.8 grams divided by, and the total length of the thread. So up to total length is from 24 to end of the thread up to pan. Okay, total length of the thread in centimeter. Okay, 100 plus 43, 143. That is the total length of the thread is 143. In this way, you can calculate m value. So after that, calculate the root m value and substitute that value in this given formula. Nu is equal to 1 by root m into root t by L value. Okay, root t by L value can get from the tabular form, and the root m value is 0.8 grams by 143. Okay, this way you can calculate frequency of tuning fork in a longitudinal mode. After that, we have to set a tuning fork into transverse mode. So here the vibrations generated by the tuning fork are perpendicular to the length of the thread. Right? The vibrations generated by the tuning fork, electrical tuning fork, perpendicular to the length of the. So here francs vibrate like this. Francs of tuning fork vibrate like this. So these vibrations are perpendicular to the length of the thread. These vibrations are perpendicular to the length of the thread. So it is a transverse mode. In this mode also, we have to calculate a root t by L value from this tabular form. Same procedure as like longitudinal method. Okay, mass in pan, that is m1 grams, total mass, the pan mass plus mass added in pan. Tension in string is equal to total mass into G value. Length of the n loops, length of each loop, that is a small l, and final column root t by L value. So here place some weight in pan. Okay, 5 grams or 10 grams, 15 grams, 20 grams, 25, like that. Okay, for every grams we have to calculate number of the loops, length of the loops, and the root t by L value. So finally calculate the average value of root t by L value. Finally calculate average value of root t by L, and substitute that value respective formula, that is a transverse mode formula. Nu is equal to 1 by 2L the root of t by L. So this formula can be written as 1 by 2 root m into square root t by L. Okay, 1 by 2 square root m into root t by L. Okay, from the table you can calculate a root t by L value, average root t by L value. Substitute that value in this formula, and again you can substitute root m value, that is the linear density of the thread. By substituting these two values in this formula, you can get the frequency of the tuning fork. This is a transverse mode. Okay.